Hello everyone, in this video we are going to see how to find the solutions of first order nonlinear PDEs. So first let us see what are nonlinear PDEs. A first order nonlinear PDE is a PDE where the unknown function and its partial derivatives do not appear linearly. So the general form is f of x comma y comma z comma p comma q is equal to 0, where p is dou z by dou x and q is dou z by dou y. And in this equation, we may have the products of p and q, or we may have the higher powers of p and q. That's why the given equation is known as nonlinear. So now let us see the solution of the PDE. A solution of a PDE is nothing but a relation between the independent variables x and y and the dependent variable z. So which satisfies the given PDE. There are four types of solution we have that are known as complete solution, particular solution, singular solution and general solution. So for any nonlinear PDE, we can find all these four solutions. So what is a complete solution? A solution which contains as many arbitrary constants as there are independent variables is called a complete solution. And in the complete solution, if we give particular values to the arbitrary constants, we get a particular solution. And differentiating the complete solution with respect to the arbitrary constants and elimination of those constants from the last three equations gives the singular solution. And in the complete solution, if we take one constant as a function of other and then differentiating that equation with respect to that constant and that elimination of that constant from the last two equations gives the general solution. So here we are going to classify our nonlinear PDE as follows. That is type 1 PDE, type 2 PDE, type 3 and type 4. Here type 2 PDE is known as Clairaut's form. So now let's see how to solve type 1 PDE. So type 1 PDE will be of the form f of p comma q is equal to 0, which means here we'll be having a function of p and q alone. P is first order derivative dou z by dou x and q is dou z by dou y. So here the PDE may be nonlinear. That means we may have the powers of P and Q, or we may have the products of P and Q, but we have only P and Q but not RST. RST are second order derivatives. So we'll be having only an equation involving P and Q. That is called type 1 PDE. So here the solution is assumed as z is equal to ax plus by plus c. So first we have to reduce the constant in this solution because now we have three solutions. So our objective is we have to reduce one constant from this so that we'll be having equal number of constants as the number of as the number of independent variables because the number of independent variables are x and y. So here we have two independent variables, means the solution should involve two arbitrary constants, but now we have three arbitrary constants. So our objective is to reduce one constant in this solution so that we get a complete solution in this form. So for we replace P as A and Q as B in the given equation, and then we write A as a function of B or B as a function of A, and substituting this in this assumed solution, we get our complete solution in this form. And then we find our singular solution just by differentiating the complete solution with respect to the arbitrary constants A and C, and then elimination of those constants gives the singular solution. And then finally taking C as function of A and differentiating with respect to A and elimination of A gives the general solution. So now we'll see one example. So this is what our given problem. Here we are going to solve this nonlinear PDE, and this is of type 1 PDE because this PDE contains only P and Q. Okay, so here first we assume that our solution is, let z is equal to ax plus by plus c be the solution of the given, be the solution of 1. So let us name this as 1. Okay. So now we have to replace p as a and q as b in 1, which gives a plus b is equal to ab. So from this we get a plus b minus ab is equal to 0, and from this we get a plus b into 1 minus a is equal to 0, and from this we get b is equal to minus a by 1 minus a, or else we can write the same as a by a minus 1. So now replacing this b in terms of a in the assumed solution, we get our complete solution as z is equal to ax plus b can be taken as a by a minus 1 into y plus c. So now this solution involves only two arbitrary constants, a and c. So now this solution is complete. So next we are going to find the singular solution. For type 1 form of PDE, singular solution does not exist, because when you differentiate this complete solution with respect to C, so we get differentiation of this with respect to C, we get left hand side is 0 and the right hand side is 1. So which is absurd. So from this what we can conclude? Which is absurd, which means singular solution does not exist. So no singular solution for type 1 form of PDE. Okay. Next, how to find the general solution? For general solution, we have to take one constant as a function of other. So we are going to take C as function of E. That is, let us take Z as ax plus a by a minus 1 into y plus function of A. So now we have to differentiate this with respect to A. So left hand side is 0 and it is x plus here we have u by v form. Keeping this a minus 1 fixed and differentiating the numerator is 1, minus keeping the numerator fixed and differentiating the denominator is 1 by a minus 1 the whole square into y plus f dash of a. So now elimination of a from these two equations gives the general solution. So elimination of a from 3 and 4 gives the general solution. So similarly, we'll try one more problem. See, this is a second example. Solve q square minus 3q plus p is equal to 2. So again we have a first type of nonlinear PDE, because this PDE involves only p and q. So now we'll see the solution. So here for the first form of PDE, we assume our solution is z is equal to ax plus by plus c. Now we have to reduce one constant in this to get our complete solution. For we replace p as a and q as b in our given equation. So we get b square minus 3b plus a is equal to 2. From this we write a in terms of b, that is a is equal to 2 minus b square plus 3b. So now substituting this a in that assumed solution, we get our complete solution. So the complete solution is that is equal to, we are replacing a here, so it is 2 minus b square plus 3b into x plus by plus c. So this solution involves only two arbitrary constants, b and c. So now the solution is complete, because the number of independent variables are x and y. So we have two number of independent variables as well as the arbitrary constants also two here, that are B and the C. So we can say the solution is complete now. So next we have to find the singular solution for differentiating this complete solution with respect to the arbitrary constants. So differentiation of this equation with respect to C gives 0 is equal to 1, which is absurd again. As I said already, type 1 form of nonlinear PD has no singular solution. So which is absurd, so which has no singular solution, has no singular solution. So how to find the general solution? For we have to take one constant as the function of the other. So we take z as f of a function of b, because here the other constant is b. So we take c as function of b. So we get z is equal to 2 minus b square plus 3b into x plus by plus function of b. So now differentiating this with respect to b, we get left hand side is 0 and in the right hand side it is minus 2b plus 3 into x plus y plus f dash of b. So the elimination of b from 3 and 4 gives the general solution. Elimination of b from 3 and 4 gives the general solution. That's it. I hope you understand how to solve first order nonlinear PDE of type 1 form. Thank you.